All right, we're going to look at double angle and half angle identities. So earlier in the week, I just straight up told you how to find the sine, cosine, and tangent for the sum of two angles or the difference. Today, I actually want to develop this because you will see where this comes from. And I'll do it just for this one and hope that you would take my word for the rest of them. Otherwise, you could look in the textbook on page 448 and they sort of describe the rest of them. So if I think of the sine of 2 theta, this really is the sine of theta plus theta. And earlier in the week, we said that the sine of a sum of angles, it will be equal to the sine of the first angle times the sine of the second angle, plus the cosine of the first angle times the sine of the second angle. And since both of my angles are theta, I'm just theta-ing this thing all the way across. Well, think about this. This is sine times cosine. This is sine times cosine. So what we actually have are like terms. So we really could just combine these two like terms. Excuse me. So you'll see that the definition here is that the sine of 2 theta equals 2 times the sine of theta times the cosine of theta. Likewise, we could do the same thing for the cosine of 2 theta, but you would find that this just becomes cosine squared theta minus sine squared theta. And the reason I didn't develop this one in a similar matter is because this opens up a whole can of worms. Because I want you to remember this. Remember the trig identity, my favorite identity. Cosine squared theta plus sine squared theta equals 1. Well, I'm going to use that here. All right? So in order to solve for cosine squared theta here, I can subtract sine squared theta from both sides. Okay? And then I'm actually going to substitute this for cosine squared theta. This will equal 1 minus sine squared theta minus sine squared theta. And when I combine my terms, I bring down my 1. Negative sine squared theta minus sine squared theta is negative 2 sine squared theta. Okay? So as of this moment, we have two different definitions, per se, or formulas for cosine of 2 theta. We've got this one, we've got this one. I'm actually going to have a third one. And the third one will involve solving for the sine here. So sine squared theta plus cosine squared theta equals 1. I'm going to solve this now for the sine. So in order to solve for sine squared theta, I can subtract cosine squared theta. I would find that sine squared theta is 1 minus cosine squared theta. So I could actually go in here. Oh my goodness, I could actually go in here and rewrite it, okay? So if I bring this down, 1 minus 2, and check this out. Remember, sine squared theta is 1 minus cosine squared theta. This becomes 1 minus 2 plus 2 cosine squared theta. 1 minus 2 is negative 1 plus 2 cosine squared theta. But we don't like to leave negatives hanging out because they may drop by accident. So let's just rewrite this as 2 cosine squared theta minus 1. And this is actually the third formula that I can use for cosine of 2 theta. Man, I just threw a whole bunch at you. So let me summarize those for you, okay? So cosine of 2 theta actually has 3 different identities. It is cosine squared theta minus sine squared theta. That's what we originally started with. It is also 1 minus sine squared theta, or minus 2 sine squared theta. And then it is also 2 cosine squared theta minus 1. So this one's interesting because it has so many different interpretations. It's nice because if I'm only given the sign, I could easily find the cosine of 2 theta or whatever the case may be. So these are the 3 different ways that I can rewrite the cosine of 2 theta. And then the last one that we would look at is the tangent of 2 theta. The tangent of 2 theta, I'm just going to give you the formula. You can see how it's derived on page 449 of the textbook. The tangent of 2 theta is 2 times the tangent of theta times 1 minus tan squared theta. Okay, so those are the definitions we're going to use. And now let's actually work a few out. And I think to make your life easier and my life easier, I may just work through a few of the book examples just to make sure everything's clear. Actually, I'm going to leave the book examples for you to kind of figure out on your own, just to have another source of how to figure out things. I'm actually going to do some of the problems from page 453. Okay, so that was a sudden change. And I can't change my mind on video, otherwise I would stop and start from the beginning, and that's just not going to happen. So let's look at page 453, number 8. All right. If the sine of theta is 2/5, and I have this craziness, remember what this does is this limits us to the first quadrant. This tells me I'm in quadrant 1. So my sine, my cosine, and my tangent will be positive. Okay. They want me on number 8 to find the sine of 2 theta. They want me to find the cosine of 2 theta and the tangent of 2 theta. Right, so let's see, where would we want to start? Okay, so I look here at my different definitions. So the sine of 2 theta will require me to find the sine of theta and the cosine of theta. I know the sine of theta, so I'm going to use my right triangle trig to help me find the cosine of theta, because it looks like here I will need the cosine of theta. And once I know the sine of theta and the cosine of theta, that will help me find the tangent of theta to use here to find the tangent of 2 theta. Okay, so let's get a little work done here. Let me go ahead and draw my triangle. And I'm in the first quadrant, so that's how I'm going to draw my triangle. All right. So sine, remember, is defined as the opposite divided by the hypotenuse. So my opposite length is 2. My hypotenuse is 5. So according to the Pythagorean theorem, this is 5 squared minus 2 squared. So this would be the square root of 21. Okay? So now that I know that, I know that the cosine of theta equals the adjacent divided by the hypotenuse. And I'm tripping. I don't need sine and cosine to find tangent. I've got all the information I need here to find the tangent. So the tangent of theta equals opposite over adjacent. All right, so let's figure out how this works. So the sine of 2 theta equals 2 sine theta cosine theta. Okay, so this is 2 times 2/5 times square root of 21/5. Let's see, 2 times 2 times that radical, we get 4 square roots of 21. 5 times 5 is 25. Okay, so that's how we find the sine of 2 theta. The cosine of 2 theta is the square of the cosine minus the square of the sine. So this is the square root of 21/5 squared minus the sine 2/5 squared. So when you square the square root of 21, you just get 21. When you square 5, you get 25. When you square 2, you get 4. When you square 5, you get 25. So this is 17/25, because remember, we'll subtract the numerators and keep the same denominator. All right, tangent of 2 theta. That equals 2 times the tangent of theta divided by 1 minus tan squared theta. All right, so this is 2 times 2 over the square root of 21 divided by 1 minus 2 over the square root of 21 squared. Oh, I'm going to run out of room. Okay. So this becomes 4 divided by the square root of 21 divided by 1 minus 4 over 21. All right, work with me here. This is 4 divided by the square root of 21 times, why am I multiplying? Because this is going to be a fraction. This is 21 over 21 minus 4 over 21, which is 17 over 21. But when you divide by a fraction, you multiply by its reciprocal. So 4 times 21 is 84. The square root of 21 times 17 is just 17 square roots of 21. Okay, Robodeer, that's fine and good and all that jazz, but I don't want to revisit right triangles. I still have PTSD from August, and I get that. And besides that, Robodeer, you just talked to us about using identities. So show me how to do this same problem using identities, because that's what the book does. Okay, let's do that then. Let's look at it again. The sine of theta is 2/5. Again, we're bound by the first quadrant, so I need to find all my double angles. All right. All right. So we have to find the cosine. Well, here's what I know. I know that sine squared theta plus cosine squared theta equals 1. I know the sine is 2/5. So this becomes 4/25, right? Because 2 squared is 4, 5 squared is 25. Now I need to find the cosine. So let's subtract 4/25. We get cosine squared theta is 21/25. And if you don't believe me, use your calculator. Find all this on there. I'm not going to tell. No one knows that you're going to be using your calculator to add and subtract fractions. How do you know I don't have one in the background here that you can't see that I'm not using? Exactly. Okay, so to solve for the cosine, we need to take the square root of both of these. But remember, you always have to consider the positive and negative square root. At least that's what my Algebra 1 teacher, who might have been me, and my Algebra 2 teacher told me. So this becomes the cosine of theta equals the square root of 21 divided by the square root of 25, which is 5. Okay? So here we have it. We have the algebraic version where we see that the cosine of theta is the square root of 21/5. And we have the right triangle version to see that the cosine of theta is the square root of 21/5. Do I care which one you use? I don't. If I cared which one you used, if I wanted you to use a particular one, I would have only shown you one way to do this. All right? So now we know the cosine is the square root of 21/5. And then we need to find the tangent. Let's actually do that here. The tangent of theta is the sine divided by the cosine. My sine is 2/5. My cosine is the square root of 21/5. And the cool thing here is my fifths will divide out, and I'm left with 2 divided by the square root of 21, which, oh my goodness, that's what I got right here. So see, either way works. All right, so now let's find these things. The sine of 2 theta is 2 sine theta cosine theta. All right, I just did this. I bet if you rewind the video a couple of minutes, you'll hear the same thing. Okay, and when I do this, 2 times 2 times the square root of 21 is 4 square roots of 21. 5 times 5 is 25. Almost did it. Almost tried to distribute where I shouldn't. The cosine of 2 theta, it's the cosine squared of theta minus sine squared theta. Okay. Oh, let's use a different one. No, let's just finish this. So the cosine of 2/5 is the square root of 21 fifths squared minus 2/5 squared, and that's 21 25 minus 4 25, which is 17 25. I mean, I really thought, okay, let's do this one. Yeah, let's do it. We can also say it's 1 minus 2 times the sine squared theta. Why would I use that one? Because it's given to me way up here. And sometimes I don't trust my work. So let me use a sure thing. So this is 1 minus 2 times 2/5 squared. This is 1 minus 2 times 4 25, which is 1 minus, let's see, 2 times 4 is 8 25. And I'm going to humor y'all. 25 25 minus 8 25 is, oh my goodness, 7 25. Matchy matchy. So regardless of the formula I use, I'm going to get the same answer. Okay. And let's nestle our tan squared of theta snugly under the tangent, because we are going to use this expression here to help us. So the tangent squared of theta, if I'm going to be wiser this time, it's 2 times the tangent of theta divided by 1 minus tan squared of theta. So it's 2 times 2 divided by the square root of 21 divided by 1 minus 2 divided by the square root of 21 squared. That's 4 divided by the square root of 21. This is 1 minus 2 over 21. No, Denise. 4. This becomes 17 over 21. I ran out of room anyway. So we get 4 divided by the square root of 21 times 21 divided by 17, which equals 84 divided by the square root of 21. So no matter what, I'm going to get the same value. Okay. All right. So you would use that for, if I ask you to find, where would I use things like this? Well, let's say I want to know the sine of, well, that wouldn't work. I was trying to think of angles that we can use for our, to use our unit circle, but I don't think that helps, because when you double 30, you get 60, which is on the circle. You double 40, you get 90, which is on the circle. You double 60, that's 120, which is on the circle. So yeah, so this will be used mainly whenever I give you a sine or a cosine, and I want to know it's double. Okay. All right. So that's how you would use your formulas, your identities, to find the sine, cosine, and tangent of double angles. Now, that is only half of the lesson. So we talked about double angle. Now we need to talk about half angle identities. All right. So let me go to a clean sheet of paper here. All right. Let's see. All right. So here we go. To find half angles, and I'm just going to straight up tell you these. The sine of some angle divided by 2 is the positive or negative square root of 1 minus the cosine of the angle divided by 2. So again, we'll be making more right triangles, or you will be using more identities to help you with this. The cosine of a half angle is the positive or negative square root of 1 plus cosine of the angle divided by 2. And then the tangent, is sort of the quotient of these two, right? Because the tangent is the sine divided by the cosine. All right. So this is the positive or negative square root of 1 minus cosine of alpha divided by 1 plus cosine of alpha. So for half angle identities, please make sure you know that we're using the cosine for all of these. All right. So how do we use this? All right, I'm going to leave the book examples for you on page 451. Okay, so, it's example number 2. You read it. Okay. All right. I'm actually going to look at 2 examples for this. All right. So here are some examples from the exercises. If we look at page 453, let's look at number 6. I want to know the sine of pi over 8. Well, dang. So, when we did sum and difference formulas, you had to think of 2 numbers that added 2 numbers on the unit circle that added to a particular angle. Here I have to think, okay, I'm dealing with half angle identities. What is this half of? Well, this is half of 2 pi over 8, or this is half of pi over 4. And guess what? I know this stuff for pi over 4 from my unit circle, okay? On my unit circle, pi over 4 is root 2 divided by 2. Root 2 divided by 2. Man, that's going to be nice. Okay, so according to my formula, I'm going to be using this one, okay? Sine of pi over 8 is really the sine of pi over 4 divided by 2. Okay, these two things are the same. When you take half of pi over 4, you're dividing by 2. So let's make a note of that. These are equivalent. Okay. So in my formula, you'll see here I've got the angle divided by 2. So the angle I'm looking for goes there. Okay. So this we have to consider positive or negative square root of 1 minus the cosine of pi over 4 divided by 2. And you're probably wondering, Robert, dear, why do I have positive or negative here? Because it didn't define us to any one quadrant. We have to consider all quadrants. And in all quadrants, the sign is either positive or negative. This covers both cases for me. Okay. So I keep my plus or minus. I'm going to bring in my radical. The cosine of pi over 4 is the x-coordinate. Square root of 2 over 2, and we will divide by 2. And good night. We've got some crazy fraction action happening here. All right. I'm going to treat this as 2 over 2. Okay. So this is the positive or negative square root of 2 over 2 minus the square root of 2 over 2. Okay? Let's just do this for now. This is 2 minus the square root of 2 divided by 2, all divided by 2. Goodness. All right. And what happens when we divide by 2? We are actually going to be multiplying by 1/2. Boy. So here's my first fraction. I'm going to put that here. Multiplying by 2, or dividing by 2 means we multiply by that. Whoa. All right. So here we would get positive or negative square root of 2 minus the square root of 2 divided by 2 times 2, which is 4. And think about this, guys. When you take the square root of a fraction, it is a fraction of square roots. So we're actually going to get the positive or negative square root of 2 minus the square root of 2 divided by 2. Wow. Okay. Now, yes. So I was wrong. I do have to consider a positive or negative case. Oh gosh, this takes me a minute. All right. So where is pi over 2 located? Or pi over 8? Pi over 8 is located in quadrant 1. So the sign of pi over 8 is positive. So when I report my answer, I only consider the positive case. Wow, I'm glad I figured that out before I submitted this video. Okay. Pi over 8 is in quadrant 1. The sign in quadrant 1 is positive, so we should only consider the positive case. Okay? And Robadeer, you totally blew me. I don't understand what I'm supposed to do with that. That's fine. I'm going to show you one more, and then we'll end this for the day because I'm already at 27 minutes or 28 minutes. Okay, let's look at another example. Let's look at page 453, and this is number 7. Okay, I want to find the tangent of 165 degrees. Okay, so first I start thinking of sum and products like I do in my unit circle. So that would be you know, oh, I guess I could do 120 plus 45. That may be fun. But then when I look back at my tangent, it's a little too much work. So I think I would do this as half of 330. So this is the tangent of 330 degrees divided by 2. All right? And so I will follow my formula. Let's see, where is 330? 330 is almost it's right here. Okay. So I have to think about the values on my unit circle that give me the tangent of 330. And if you hear some noise in the background, yes, that is me going back to my unit circle that's in the textbook so I can find these values. Okay. Excuse me. So that's why I guess I don't want to use 120 plus 45 because then I have to find 2 different values. And man, it's so much easier just to figure this part out. All right, so we're going to use our formula, okay? We're going to use this formula here. All right, so this is the positive or negative square root of 1 minus the cosine of 330 divided by 1 plus the cosine of 330 degrees. All right, so let me look up this one really quickly. So when I look at 330 degrees, I know there's a nice little chart somewhere in here. Okay, I can't really find it. So 30 I think this is the square root of 3 over 2. Yeah, so when I look at my 30-degree angle, this is a 60-degree angle, and remember, the shorter side is always across. And then this is the square root of 3. I believe that's what I'm going to use. Excuse me. So when I look at this problem, this will be 1 minus square root of 3 divided by 2 divided by 1 plus the square root of 3 divided by 2. Oh my gosh, this already looks a little crazy and I'm a little nervous. Can't see it because I'm not on video. I'm going to go ahead and split this up, okay? So this becomes the positive or negative square root of 1. I'm just going to rewrite it for myself so I'm not backed up onto the edge of the paper here. Okay. So again, I'm going to use some common denominators here. This is really 2 halves. This is really 2 halves. So this is positive 2 minus the square root of 3 over 2 divided by 2 plus the square root of 3 over 2. Okay. And this becomes 2 minus the square root of 3 divided by 2 times. All right. This will go here because I'm dividing by a fraction. Let me extend this radical. Good night. So this becomes 2 divided by 2 plus the square root of 3. That's the second fraction, and I find it's reciprocal. And when I do that, my 2's will divide out. I get that this is the positive or negative square root of 2 minus the square root of 3 divided by 2 plus the square root of 3. And then that becomes a little crazy because the answer on the back of your book is going to be a nice, pretty number. So I think what I want to do is I wonder if my calculator will do this for me. 2 plus square root of 3. Okay. Okay, so it does give me a clean answer, but I think just for now, I'm going to leave this one as is. Okay. I could do all the work and it gives me that it's the positive or negative 4 square roots of 3 plus 7. But the key point here is that 165 degrees is in the second quadrant. Okay. And in the second quadrant, tangent is negative. Okay. So for this, my final answer, I'm going to just use the negative part because that's quadrant 2. Nope. Okay. So it's the square root of 2 minus the square root of 3 divided by 2 plus the square root of 3. Okay. So anyway, that's what this section is all about. If you have any questions, I am available by email. Thanks.